So this lesson's on measurements and conversions. And as you can see, there's going to be two different methods for making conversions. First, it builds on what you did yesterday, which was using a proportion. And as it says, using a proportion is best when you just have a single conversion factor that you can use. We're also going to talk about a topic called dimensional analysis. And dimensional analysis works really, really well when you have a bunch of different conversion factors going on. Let me show you what I mean. So the first one will be using a proportion. And when you use a proportion, you use what's called a unit rate. So the reason why these are called unit rates, some of these conversions here, is that, for example, in this first one, where it says 1 inch equals 2.54 centimeters, the unit rate for that is every 2.54 centimeters is equal to 1 inch. Most times, that means that the denominator can be written as a value of 1. So it's 2.54 centimeters for every 1 inch. The denominator doesn't have to be 1, but if it is 1, it might make our calculations a little bit easier. This list of conversions comes from a formula sheet that you'll be given on your Regents exam. We'll also be giving this formula sheet to you in class as well. So if you need to use one of the conversions from here, you can. Now, if there's a conversion that is not on this list, we would probably tell you what it is. For example, if we wanted to convert maybe the number of tablespoons in a cup, or if we wanted to figure out how many gallons of water make up a cubic foot, maybe we would give you those conversions as well. But these are ones, and if you look at them, they're pretty common as well. So our first question is, how many feet are in 3.1 miles? 3.1 miles is a 5K race. The people that run cross country know that. So we want to know how many feet do they run. So if I write my first proportion here, I want to know how many feet, we'll call X the number of feet, are in 3.1 miles. And using a proportion, I want to make that equal to another unit rate. So the one I'm going to choose is going to be this one right here, where 1 mile equals 5,280 feet. I want to make sure I put my units in the right spot. So I'm going to put 5,280 feet to go with the feet in the numerator, and I'm going to put 1 mile on the bottom. So as we learned yesterday, we want to solve this maybe using reciprocals. I noticed that the variable's in the numerator. So instead of dividing by 3.1, I'll undo this by multiplying by 3.1. And actually what I'm going to do is I'm going to highlight something here. I'm multiplying by the idea of 3.1 miles. And I want you to notice what happens to these units now. The units of miles cancel out. I know that the 3.1 cancels here as well, but that's really important on the right side of our proportion, because the units miles cancel out, and the only units that are remaining now are feet. So we know that our answer is going to be the number of feet we have. So let's try to pay attention to those units. As we go over here to our calculator, I'll take my 5,280 feet and I'll multiply it by 3.1. So 3.1 miles, when you run that cross-country race, you've run 16,368 feet. 16,368 feet. That's how far you run when you run 3.1 miles. That's pretty far. So next we want to introduce a topic called dimensional analysis. And if you remember, dimensional analysis is really helpful when you have multiple conversion factors. Because if I see this example here where a radio-controlled car travels 30 feet across the floor in 1.6 seconds. So the speed on this is feet per second. So I got two different dimensions going on here. I have two different conversions. I have a feet and I have a seconds. I have a distance and a time. And we want to know it's miles per hour. So there's different conversions here. So first, what's the speed of the car as a ratio? Well, I learned yesterday that a ratio is a fraction. So I can write 30 feet is to 1.6 seconds. That could be our unit rate for the car. Again, the unit rate doesn't have to have a denominator of 1. But we're going to need other unit rates, because let's think about what we want to do. We want to be able to convert feet to miles. So we had that one from before that said 5,280 feet is equal to 1 mile. So we have another conversion though. We need to go from seconds up to hours. Do you know how many seconds are in an hour? I'm not too sure either. But what I do know is I know how many seconds are in a minute. And then from minutes, I can go to hours. So I know that there's 60 seconds in a minute. And I know there's 60 minutes in an hour. So these are my unit rates that I'm going to use. Let me show you how we're going to use them. We're not going to write a proportion. We're going to actually write a product. So I'm going to start here with my unit rate from the problem that I'm given. And I was told that that car goes 30 feet in 1.6 seconds. Now, the idea here is that I'm going to set up all of my units so that they cancel except the ones that I need. So here's what I mean by that. I'm going to start canceling my feet. So I had that conversion that 5,280 feet was equal to 1 mile. Well, I got to think, if I'm going to cancel my feet, if I'm going to cancel my units, I want them to be opposite each other. So I'm going to put my feet on the bottom, my miles on top, and I know that 1 mile equals 5,280 feet. So let's continue. I had another unit rate of 60 seconds equals 1 minute. Seconds are in my denominator, so they need to go in my numerator to cancel those units. And we knew that we had 60 seconds was 1 minute. And then finally, we want to cancel minutes and change them to hours. And we know that there's 60 minutes in an hour. So before we go multiplying, let's check out what cancels here. Feet cancel. Seconds cancel. Minutes cancel. Look at the units that we're left with. We have miles and we have hours. So in our answer, the units are going to be how many miles per hour. So let's go to the calculator and multiply them out. And one thing I notice is that the ones don't really need to be multiplied. So what I'm going to do is I'm going to go over to my calculator. Check this out. I'm going to go Control Division. I'm going to make a fraction. So I know my numerator had 30 feet in it. And then we had the 60 seconds and 60 minutes. So I'm going to multiply 30 by 60 times 60. My denominator had my 1.6 seconds times 5,280. So this product will tell us how fast that car is going. So if we go back here, I think that should be our answer. If we round it, it's 12.8. So instead of making this big old fraction bar, we can do this and just write 12.8 miles per hour. Or, are you familiar with 12.8 mph? That works too. So let's work through one more together. If you ride your bike competitively, you know that you might be able to travel about 15 miles in an hour. And we want to know how many feet per second does this cyclist travel. So think about how we start. We have our unit rate, 15 miles in an hour. So 15 miles in 1 hour. Now let's think about conversions that cancel out. If I want to cancel my miles, miles go on bottom, and I want to change that to feet. Let's also change hours to minutes. Let's also change minutes to seconds. So if you need to go back to your conversions, we have 5,280 feet in 1 mile. We have 1 hour is 60 minutes. We have 1 minute is 60 seconds. Going back to our calculator, I'll do that control division again. That makes that fraction template. And we have 15. And I think we're multiplying by the number of feet in a mile, 5,280. And we're going to divide that by 60 times 60. So a cyclist who travels at 15 miles per hour is traveling 22 feet for every second. That's pretty fast. So hopefully this video helps you to understand conversions can be done using proportions and also using dimensional analysis.